welcome to our webinar, Maximize Success with Digital Forge Subscriptions. We appreciate you taking time out of your day to spend time with us to learn more about what Digital Forge subscriptions are. I'm joined by Julie Vanderhoop. She is our product manager covering a lot of our software products and subscriptions. My name is Rick Dalgarno, and I am Julie's counterpart in product marketing. So here's the agenda for today. We'll do a quick introduction to the Digital Forge. That's our platform covering hardware, software, and materials. And then we'll get into the primary focus of the webinar, which is Digital Forge subscriptions. We'll talk about the 3 pillars of subscriptions. That's software, support, and training. And then we'll close with a couple of customer examples of people who are using these technologies to really drive value with their companies. And then we'll finish with a summary and a Q&A. So first, I want to talk about the Digital Forge. All right, so we develop and manufacture and sell a very robust, simple, smart, and empowering digital platform that brings the power of agile software engineering to the world of industrial manufacturing. So this platform that you engage with is what we call the Digital Forge, and that's a collection of our hardware, our software, and our materials. And those have all been designed and purpose-built from the ground up, and they work in concert together to deliver quality, reliability, and repeatability. And so because we have control over all these variables that are associated with the 3D printed parts, we own the value chain, and we can ensure the success of you, our customers. The best thing about the Digital Forge is it's continually improving, and it's going to transform the way our customers manufacture. We do offer a complete line of 3D printers, all designed around one goal, and that's putting functional parts into your hands right now. All of our machines combine high build quality, intuitive user experience, and broad platform connectivity. They feature unibody aluminum frames and precision ground mechanical components. Markforged printers produce reliable, repeatable results, and better yet, the 3D printers continually improve in performance over time. We have a team of engineers that are regularly updating the hardware through cloud updates to add new features and improve performance. Now, I'm not going to go into details on each of these printers, but we print in plastic, composite, continuous fiber reinforcement, and metal using fused filament fabrication, or FFF, or FDM, metal FFF, and our newest technology, which is binder jetting. Speaking of that new technology, that's our PX100. This is our binder jetting printer with production fabrication speeds and industry-leading part resolution. So speaking of materials, these are the plastic and composite materials we offer for our desktop and industrial FFF product lines. Starting with continuous fiber, this is a huge differentiator for us here at Markforged. It really sets us apart from the competition. We allow you to embed continuous fibers that can be Kevlar, carbon fiber, fiberglass. You can embed these continuous fibers inside your parts, which allows them to be really stiff, really strong, and durable, but also lightweight. We also have Ultim 9085. This is a high-performance thermoplastic that you're often going to find in aerospace applications. What's really cool about this material is that it is compatible with our continuous carbon fiber, so you can combine the benefits of Ultim with the benefits of continuous carbon fiber. Our composite-based materials. Onyx, that's our workhorse material. It comes in a couple of varieties. This is a micro carbon fiber-filled nylon plastic. It's a great general purpose, strong material, and it's known for having best-in-class surface finish. Precise PLA is a great material for doing concept and ideation, fit checks, and refinement. Smooth TPU is a recent material that we've added. This is a rubber-like material. It's flexible, super tough and durable, and it also has a great surface finish. In terms of our metal materials for FFF, we have a range of materials here, stainless steel all the way through copper. These allow you to easily print 3D printed parts for metal applications. In terms of our binder jetting materials for the PX100, there's also a wide variety here, including 2 types of stainless steel, several alloys, copper, and even titanium. This technology in particular is great for high volume production parts that have complex geometries. And I just had to show this recent product photo here on the right. This is an actual part that was printed on the TX100, just showing the amazing resolution and detail that you can get from this technology. And this just kind of highlights the value of us owning the value chain, right? Of us owning and developing the software and the materials and the hardware, getting all those components working in concert together and calibrated so that we can get these reliable, high precision parts. And we're solving problems for the world's leading companies, right? We serve a broad and diverse range of industries. We're not just serving one niche industry. Our customers are solving problems and adding value for their organizations and their customers through this digital forge. Everything from industrial automation, manufacturing, aerospace, automotive, and healthcare. So I'm going to pass the ball over to Julie, and she's going to introduce us to Digital Forge subscriptions.
Awesome, thanks, Rick. So I wanted to give some context of, why would we introduce a subscription that combines all of those elements of the Digital Forge that Rick just mentioned? So our software, our printers, our materials. And the rationale really is, you can go to the next slide, Rick, that previously our software offerings were standalone. So we had these great software offerings of Blacksmith. This is our in situ inspection and kind of tolerancing tool. We have offline Eiger for some of our more restricted environments. Eiger Fleet to really bring together these large distributed networks. And most recently, simulation, the technology that allows you to validate and optimize part performance before even printing. And that's great, but all of these offerings were standalone. They didn't work in concert with each other, and they weren't really part of this bigger thing that is the Digital Forge. The other thing is that these products were sold a la carte. So in this example, I have one seat of Markforged University. Maybe for my first two printers, I buy Blacksmith, and I get offline Eiger for a short period of time because of a certain new project. When I buy my third printer, I have Blacksmith and a success plan. So now I have this very complex situation of multiple printers with different products on them, different terms, and different access. And that's just a kind of disaster to manage for our customers and for us as well to help you succeed. So what we've done with Digital Forge subscriptions is really to pull all this together. So if a customer here gets the advanced subscription that we'll talk about in a moment, this covers all of your printers. It's available, all the software functionality is available for all of your users in the organization. And you get all of the software functionality that's included in that tier. This is all on a single term and all on one contract. So from a management perspective, it's way easier to know. I buy this one thing, it covers everyone. I'm not having to choose what is covered where and to manage that separately. So really bringing these pieces all together that are the different components of the Digital Forge and making them all available to our customers in one single subscription. Just a high level view of our Digital Forge subscription tiers and what we've just brought to market. The basic tier here is really just a lot of the core Eiger functionality that you know today, which helps you create strong functional parts securely. The differentiation really comes in these other tiers, the Essential, Advanced, and On-Prem. Essential is really focusing on our management and integration suite. This is previously a lot of the functionality that was in Eiger Fleet, and we're bringing this to a lot larger of a customer base because we realize that a lot of this tooling is important for you and your companies as they grow. The advanced tier, this is the inspection and simulation software that Rick will touch on a bit more. And we do also have an on-prem deployment. This is for local file storage and slicing, very important for remote locations or where internet access is either restricted or prohibited. You can also connect here with over a private LAN. So a lot of the same networking capabilities, but more internal to you and your company. Expanding to the other components of the Digital Forge, we have materials. So helping you obtain a lot of our high functioning materials here in spool packs. So our spool packs of onyx or of carbon fiber as well on 3-year terms. We have training, so organization-wide access to Markforged University instead of those individual seats, as we mentioned. And a big difference is in our support model. So in these higher tiers, you get all of the wear and tear items, this reactive technical support, and pretty importantly, an annual machine calibration that allows you to make sure that your industrial machine is operating exactly as it needs to.
Okay, thank you, Julie, for the intro to Digital Forge subscriptions. So at a high level, I want to talk now about kind of what the value proposition here is for subscriptions. And first off, for a lot of our existing customers, many of you might assume that subscriptions are just a new rebranding of our current success plans or our previous success plans. But in fact, subscriptions are much more than just the new success plan, right? There's the software pillar, the support pillar, which is essentially the new success plan, and then the additional training components there through Markforged University. So bringing a lot more value into these offerings with the addition of support and training on top of the success plan components that you're used to today. And at the end of the day, as Julie already alluded to, this results in a product that is much simpler. It's easier to purchase, it's easier to manage, less overhead and administration, and it's easier to renew. It's also very comprehensive. Whereas before, printers were covered, some weren't, some users had access to the training software, some didn't. That's no longer the case, right? It's very comprehensive. All users in your organization have access to the software. Doesn't matter if you have 1 or 50, and the same thing with the training component. And then all devices are covered under the support plan as well here. Subscriptions are also more cost effective, and that just means that we're bringing more value at a lower cost. And so what do I mean by cost-effective pricing? I think that's best illustrated by an example. So here is an example of a customer. They've got one X7 printer and they've got 5 users. Before we had subscriptions, all of the offerings on the left were priced either per printer or per user, or in the case of simulation, it was just a free trial. It wasn't even sold yet. So if in this example, you summed up all of these features, and we just normalize this down to let's $100, right, for the before subscription price, and then we compare that to after subscriptions. If you subscribe to the advanced tier, you get organization-wide access to inspection, simulation, Eiger Fleet Technologies, Markforged University, and then those success plan components at a cost relative to the before price of $32. So that's a 68% reduction in price relative to the previous pricing. So again, every situation is going to be slightly different depending on the printers and the tier that you're in. But in general, you'll be getting, much more for a lower cost. All right, so we've talked about the 3 pillars. We're going to keep talking about these pillars: software, support, and training. Now I want to do a deeper dive on the software component. So in the essential and advanced tiers, we have what are called our management and integration features. These are all of the features that were previously in the product we called Eiger Fleet. These allow you to manage your distributed operations on an enterprise and global scale, and it's going to give you that increased efficiency, insight, and control. These are really powerful tools, particularly for organizations with multiple printers, user profiles, or locations. Here's the main feature set for this group of features. The first one is user management. This is commonly called role-based access control, or RBAC. This allows you to control who has access to what based on their role in your organization. API access. This is going to allow you to integrate the data generated by Markforged into your existing systems, giving you improved visibility and automation. Custom TLS certificates allow you to fortify your security with your own encryption. Custom analytics gives you real-time ROI visibility into your fleet. Part approval workflows. This is where you are able to review and approve parts before you allow them to be printed. And this just helps ensure quality control and ensure that parts that are being designed by your employees are meeting the expectations and meeting your standards. Batch workflow and presets. This is going to automate repetitive tasks and help ensure part consistency. And then finally, SAML single sign-on. This is going to allow you to secure your part data with authentication to your trusted identity provider. But if we step back a little bit, what do all these features allow you to do? They're going to help you reduce your administrative costs and risk. It's going to allow you to make data-driven decisions, and it's going to increase the utilization of your printers. I would do a live demo of these management integration features, but it's really just dashboards and interfaces, so it's not very exciting to look at. We'll save the live demos for inspection and simulation. So speaking of inspection, this is the product that was formerly called Blacksmith, right? Blacksmith was our standalone product. This is the in situ part scanning and inspection and reporting. So let me kind of walk through what this process looks like from a workflow perspective. The first step would be to configure your part. So inside of Eiger, which is our slicing platform, you're able to define a global scan resolution, and you can identify key features that you want to have scanned with the higher resolution. And then you scan. This is the cool part. So after you press print, we're able to scan interior, exterior features, and fiber pathing using the onboard laser micrometer that we're showing in this animation here. After the part is printed, you are able to go back into Eiger and inspect the part. And you can measure key features, you can measure relationships between features as well, and check to see if this part has met requirements and is within tolerance. And then finally, you're able to download and save that customizable scan report, showing that clear pass-fail analysis. And really what this is all about is giving you rapid and reliable quality control. As I mentioned, you can scan interior features and exterior features. It's also able to detect print failure. So if it thinks material is supposed to be somewhere and the laser doesn't pick it up, it will pause the print and alert you that something might be amiss. It's also going to allow you to get consistent parts across your entire printer fleet. So if you've got printers in Ohio and printers in Florida and maybe printer in Norway, if they're all printing the part and they're all being scanned on the same printers, on the same devices, you can get the same report and make sure that these parts are meeting your standards. And then a lot of our customers are in regulated industries. So this, and in those regulated industries where you might have mandates to do part inspection. So this provides a path for compliance in those industries. So what I want to do now is hop over to Eiger, which is like our cloud-based slicing platform. This is where you're able to upload your geometry. You can select your material, your printer. You can define print settings like layer heights, infill patterns, densities, shell thicknesses. But what we're interested in today is looking at the scan feature. This is inspection. This is the first step where I define what my scan resolution needs to be. So first, globally, I'm going to define my part scan resolution. Generally, I just would go with a low resolution to keep the scan time to a minimum. And then what's really cool is you can select specific features and define a higher scan resolution on those features. So any critical features, you will want to increase the scan resolution to give you a better measurement on those surfaces. This part also includes fiber inside the part, so I can activate the verify fiber feature. And that's really cool because while the fiber is being printed inside the part, the laser will go through and verify that fiber was indeed placed where it was supposed to be placed. There's really no other way to do this. Otherwise, you can imagine if you printed a part it'd be very hard to verify that fiber was actually inside the part where it needed to be. So overall, this step's going to take you at most 30 seconds to complete. You would then go and print the part, and that's when the part is automatically scanned using that onboard laser micrometer. When the part is done printing, you can go back into Eiger, and this is what you're going to see. Right, here is my part. I see the point cloud overlaid onto the surfaces. And you can see that globally, the scan resolution is low, but on those surfaces where I wanted a higher resolution, we see more scan points. If I've printed multiple parts, I'll see that over here in my scan history. Every time I print this part, I'll have that scan history so I can go back in time and look at different parts. I will click the part. The first thing I can do is look at the scan point deviation. So maybe I want to highlight scan points that are, outside of the 200 micrometer tolerance. So I can adjust that on the scale down here, and I can see points that are outside of that 200 micrometer tolerance. But really the meat and potatoes of this event here, and this inspection, is looking at the features themselves and making sure that they're in tolerance. So I can click on a surface, and it's going to give me some data: the number of scan points, the surface area, the normal angle deviation. So this is 0.05 degrees off of the intended angle there. If I click a different surface, it's going to show me the relationship between those surfaces. So that's the dihedral angle, which is 89.95. The ideal angle would have been 90 degrees. I can add any of these measurements or data points to the report, and I've already done that here. I've just clicked the add sign, and if I go over here, it shows up as measurement A, and then I can also enter a tolerance on that. I've entered a tolerance of 0.1 degree. So this part, even though it's not exactly 90 degrees, is within my tolerance, so it gets the green check mark. I can look at the distance between these two cylinders here. I can look at the center line angle between those two cylinders. Again, I can add those measurements to the report. And once I've added these measurements to the report, anytime I print this part again, these measurements will automatically be measured and added to the report. After I'm done inspecting, I will click Download Scan Report, and this is what I'm going to see. This is a downloadable PDF file that you can store for compliance. It's got data about the materials that were used, scan point distribution, the printer ID, the most recent date that printer was calibrated. It's got some isometric views showing that scan point deviation. And then we get down into those specific measurements that I wanted to include in the report. So here's that dihedral angle that I showed you earlier. It's going to show me the nominal angle, the tolerance that I specified, what was measured, and what that deviation is. And that's going to give us that clear pass-fail analysis. So really, inspection is just a super quick way and easy to use way to measure your parts. Now let's kind of talk about why in-process part inspection and reporting is useful to you as a customer. Traditional part inspection methods require, this kind of workflow that's shown in the gray here, where you print the part, and then you're usually going to ship it off to a different department in your organization. Or if you don't have coordinate measuring machines at your organization, you might ship that off to a third party to do those scanning and reporting for you. That process might take a couple of days or even a couple of weeks. With blacksmith or inspection, you're able to print the part, scan it while it's being printed, and then within a matter of minutes, generate that scan report. So it's just a much faster method of inspecting your 3D printed parts. This is really a technology that's a big differentiator for Markforged. This doesn't exist anywhere else in the market. So a huge value add for our customers. Next, I want to talk about simulation. Simulation is a technology that we released back in November of 2022. It was a free trial for about 6 months, and it's now included in the advanced subscription tier. What is simulation? Simulation is a is a method for looking at the structural response of your part before you print it. So it's going to allow you to understand, given your print configuration and given some load case, how stiff that part is, how strong it is. But why even simulate in the first place, right? Well, we know 3D printed parts have a lot of variables that affect how the printed part is going to perform. Things like the infill density, the shell thickness, the material that you're using, the orientation of the part on the print bed, and in our case, if you're using continuous fiber or not. These are all variables that are going to influence the performance of the printed part. So if you're not using something like simulation, how do you go about quantifying the effects of these variables? A lot of us might use our intuition, our institutional knowledge, or we might overbuild the part. You might print it solid or add a lot of fiber to it. Or if you have the luxury and the equipment, you'll print it and you'll test it. Based off those test results, you'll update the design, print it, test it, and iterate, etc., until you get a part that works. So these things all involve a level of guesswork, and they're going to lead to parts that are not optimized and may or may not even work. What's really cool about simulation is you're able to do these virtual experiments in a matter of minutes and get to an optimized part very quickly. There's two primary features here. The first one's validate. That allows you to simulate the strength and stiffness of your part using print settings that you've defined. The second is optimize. And that's where you're saying, I want my part to be this strong and this stiff. I'll let the software go through and automatically find print settings that are going to satisfy those requirements. Simulation is all about, replacing those costly and time-consuming physical iterations. It's going to help you take the guesswork out of configuring your parts. It's going to give you increased confidence that the parts that you do print are going to perform as expected. And then it's going to also unlock some of those higher value applications where you're using the more expensive materials like continuous carbon fiber. When you use those expensive materials, you want to make sure that the part's going to work so that you don't waste those material costs and those print times. So let's do a quick demo here. Again, I'm back in Eiger. What's really cool about Markforged is all of our software is in one platform, right? It's all built into this Eiger platform. You don't have to jump from one platform to the other. Slicing, inspection, simulation, all within one platform here. So the part that I'm looking at here is a material handler. This is a part that is used to lift and position blocks of raw material. I've got this part set up with default Onyx settings. And so I'll go over here to the sim view. And what we need to do now is set up what's called a load case. And that's just how this part is interacting with other parts and how it's loaded. And so we're able to select surfaces and define either anchors or loads. I'll create an anchor up here. This is a surface that can't move, right? This is where the operator is going to lift up on this tool. Down here is where I'm going to apply the load. This is where the block of material is going to rest on the part. The design load here is 100 pounds, which is 450 newtons. And then when I lift up on this part, the force will be applied opposite this direction. So I need to flip this around 180 degrees. So now I can see that on this surface, I've got a load of 450 newtons in the direction of that blue arrow. That's my load case. The next thing is my strength requirement and my stiffness requirement. So strength is related to the safety factor. So if I say safety factor of 2, that means that I don't want this part to begin to fail until the load is at least 2 times my design load. And when I say begin to fail, I'm saying the onset of damage in either the plastic or the continuous fiber. This is not the ultimate load. It's the load corresponding to the onset of damage. And then max deflection, this is just, given that load case, how much is the part going to move? I don't want this to move more than, let's say, 10 millimeters. I'll save the load case, and then I'll click validate. When we click validate, all this information gets fed up to the cloud. The part is simulated. It takes about 2 minutes for this part to complete. So if I fast forward in time here, 2 minutes, we're going to see some results from that simulation. There's 3 important things to look at here. The first one is the safety factor. Globally, the minimum safety factor computed for that load case is 1.1. So that means damage will initiate at a load factor of 1.1. That's well below our target of 2. It also indicates where that damage is going to initiate. And then we also see the max deflection down here. That's 16.7 millimeters at the end of this cantilevered arm. Both of these are red because they're not meeting our requirements. Something else you can do is you can scale up or scale down the deformation. This just gives you a visual idea of how the part's going to deform, and it helps make sure that you've set up the load case properly. All right, so as a user, what do I do now? Well, there's 2 paths I can go down. I can manually adjust print settings and keep running validations to see how those changes affect the part performance, or I can run an optimization. I'll show you that first workflow first. Let's imagine that I wanted to evaluate the performance of a solid part. So what I did is I went back into the part view. I made this a solid onyx part, went back into simulation, ran that validation. 2 minutes later, I see the results here. Part stronger, but still not strong enough. Stiffer, but not quite stiff enough. I would call this acceptable. That's basically 10 millimeters, but we're just not strong enough here. So that's good information to know. What if I wanted to add a lot of fiber into the part? So what I did in this case is I took the part with the default onyx settings, but then I added a lot of carbon fiber around the perimeter of the part. Now we see that the safety factor has gone up considerably. It's 3.71. And again, this isn't the ultimate, this isn't the safety factor corresponding to ultimate load. It's corresponding to the onset of damage in the part. And this part's way too stiff now, right? It went from 10 millimeters all the way down to 2 millimeters. So it's great that we found a part configuration that's going to be stiff enough and strong enough, but at this point, the part is overbuilt. So what would I do, right? At this point, what you want to do is run an optimization. So if I go back to my original simulation with default onyx settings, and if I run an optimization, the software will automatically adjust those print settings, trying to hit these targets here of 2 and 10. And here's what that optimized part looks like. We've got a safety factor that's just above 2 and a max deflection that is satisfying that stiffness requirement. Relative to our default onyx part, the print time's only gone up 2.5 hours. The mass has gone up 70 grams, and the material cost has gone up $176, and that's due to the addition of the carbon fiber. So really, in a matter of minutes, we've used this simulation tool to identify a print configuration that is going to meet our performance requirements. So again, going back to the question, why bother with simulation? Well, let's imagine that I was going to not use simulation and I was going to do the print, test, iterate method. So it's not a stretch of the imagination to imagine that I was going to print 4 of those parts, right? The default part, the solid onyx part, the part with a lot of fiber, and then that optimized part. If I printed just those 4 parts, that's 15 days of print time and $1,800 of material. Now let's think about using simulation, right? We did all those iterations virtually in a matter of minutes, and we were able to identify that optimized part. And so then we only need to print that optimized part once to do that physical testing to make sure that's going to work. So we've saved 12 days of print time and over $1,500 in material costs through the use of simulation. And huge value, right? Just huge value. I mean, this one case alone would, justify the cost of that advanced subscription tier. But really, what's important here is like these tools have been designed from the ground up. They're purpose built for the FFF method, and they're super easy to use. Most traditional finite element analysis tools require some level of expertise and training in order to use them. We feel that with the simulation technology, our users are up and running within 20, 30 minutes, and they're comfortable using this. All right, so that was a deep dive into software. Now let's talk about support, or what do we mean by support, right? Support is essentially our new way of referring to the success plan benefits that you guys are already familiar with. It's a fully comprehensive plan that covers all devices in your organization, and it gives you that fixed and predictable cost of ownership. So looking at the benefits in a little more detail here, every printer is going to come with that 12-month manufacturer's warranty and access to the Markforged support site. When you step up to the essential, advanced, or on-prem tiers, you get some additional benefits. The first one is defective part replacement. That's basically the extended warranty coverage. There's replacement of wear and tear items like nozzles and tubes and pulleys, but also more expensive items like print heads, print beds, and LCD screens. There's coverage for parts that are accidentally damaged. That's going to give you some peace of mind. We have on-site support and partner access to Markforged technical services. That's going to give you that reactive support, and it's going to minimize your printer downtime. Some benefits that Julie touched on already is the 10% spool pack discount for Onyx and carbon fiber. This is for subscriptions on a 3-year term. And last but not least, the annual printer calibration for our industrial printers. This is going to ensure that those printers are in peak performance, peak condition, but more importantly, it's going to enable the inspection capability. So just stepping back, the two main value points here for support are that we're going to give you that fixed cost of ownership and peace of mind, and routine maintenance and reactive support. And I just wanted to mention those two benefits again that we haven't really discussed in much detail, but are very valuable. That's that 10% spool pack discount for the 3-year term, and then also a 15% reduction in cost for subscription terms that are on a 3-year term. Those are just some additional layers of savings. Okay, finally, let's talk about the training component. The training is Markforged University. What is Markforged University? Well, there's 2 programs that we offer. One focused on metals, one focused on our composites technology. For the basic tier, your organization is going to get access to these programs for 1 year after the printer purchase. And then if you're on a paid tier, you have unlimited access as long as you're on that paid tier. These programs are really all about teaching the core concepts of additive manufacturing and about our technologies through a lot of different things, including advanced application identification and a big focus on design for additive manufacturing, so that you can understand how to take your traditionally manufactured parts and get those designed for additive manufacturing. But at a high level, these things are going to help you realize the full potential of your investment in the Digital Forge. Get those new users at your company familiar with the technology, understand the core concepts of additive manufacturing, helping to make the business case justifications for 3D printing and quite a bit more. That leads to a more successful adoption of the technology. And these courses, these programs are online and on demand, so you can take them whenever you need, whenever you want. I wanted to kind of show you what these courses look like, and so I've taken a screenshot here of the curriculum for the metals course. And this isn't the full curriculum. I just wanted to show you the majority of it here on the screen. But you can see here that it covers a ton of different topics. There's a mixture of, there's slides that we have, there's voiceovers, there's case studies, a lot of video content, there's business considerations, best practices, and a lot more. So as I mentioned, these programs are really great for new hires, but even employees who have advanced additive knowledge are going to benefit from these programs. And here's just a couple of screenshots from the training courses. This first one up here is looking at the business case justification for moving from traditional manufacturing to additive manufacturing for those soft jaws there. And then the bottom picture here just shows you some guidance on how to think about adding continuous fiber to your parts. But these are just 2 screenshots out of a lot of content here. So very thorough, very comprehensive. Before we get to the Q&A, I wanted to focus on a couple of customer stories here. This first one is from Vestas. Vestas is a global leader in wind energy. You all know that they design, manufacture, install, and service wind turbines across the globe. And they've got over 15 manufacturing plants. So this is distributed manufacturing a great example of that. They depend on numerous inspection gauges at their manufacturing facilities and even their installation sites. Before they adopted Markforged, a lot of these tools were sourced from multiple vendors around the world, and it wasn't uncommon for them to find parts that were out of spec and parts that didn't pass final inspection. The end result here was delivery and installation delays. And a lot of the times, these parts are so complicated, which means that they were very expensive to produce, and they took a lot of time to produce as well. Their solution is what they call the Direct Digital Manufacturing Program. That's DDM for short. Their DDM program already includes over 2,000 parts stored in the Eiger cloud-based digital repository. This means that any employee across the globe is able to access those parts and print that on their local Markforged printer. And here they're making use of the role-based access control to control who has access to those parts. And then with the inspection tool, every time they print those parts, they're automatically scanned and they can generate a report very quickly, giving them that quick pass-fail analysis and also allowing them to be in compliance. So what they have here is, the ability to print these approved parts, these inspected parts, using the same material, same devices at any of their manufacturing locations worldwide. Next up, we have Larson Motorsports. They are the largest jet racing team in the world. They design, prototype, fabricate, and do this all for jet engine powered dragsters. Their application here is a jet dragster steering wheel. And traditionally, these wheels are manufactured using formed and stamped aluminum sheet metal. These are just off-the-shelf wheels that they buy from a supplier, and they work for some of their drivers' hands, but not for all of them. One of their drivers has smaller hands, and so they wanted to use 3D printing to investigate how they could maybe use that technology to design custom printed, custom steering wheels. Because as you can imagine, when you're going over 200 miles an hour down the drag strip, having great control over the steering wheel and buttons within reach is very important. So their requirements for the steering wheel are that it needed to be as strong as the aluminum wheel. It needed to be lighter weight, and they wanted to make it faster. So our ability to print continuous carbon fiber made a ton of sense for this application. But as I kind of mentioned earlier, understanding where to put the fiber, understanding how much to use, and evaluating the effects of fiber, those aren't easy questions to answer. And that's where our simulation technology came in and was super valuable to them. So with simulation, they were able to quickly understand the effects of adding carbon fiber to various regions, and then they could iterate based on those simulation results. So these virtual experiments, take just minutes to complete, compared to physically testing these parts, which would have taken days and probably even weeks. So they used simulation to optimize the design, and they even printed and tested that final design to ensure that it wouldn't break. All right, so at a high level, what are the key takeaways from this webinar? I want to reiterate that subscriptions are our new way of offering advanced software support and training. With software, the engine of our software program is Eiger. That's our cloud-based licensing system. Then we're able to supercharge productivity, streamline costs with innovative simulation, inspection, and management tools that are easy to use but very powerful. On the support side, this is essentially our new success plan. This allows you to keep your devices running at peak performance with minimal downtime, with all these additional benefits of reactive support, wear and tear replacement, accidental damage coverage, and more. The training component here is the composites and metal certification programs. Again, those are going to teach you the core concepts of additive manufacturing and Markforged technologies. And again, Markforged digital forge subscriptions are simple, they're comprehensive, and they're cost effective. So what are the next steps? Maybe you're interested in learning more about digital forge subscriptions. What should you do? First thing I would recommend is reaching out to your Markforged sales representative or your partner representative. They're the ones that will be able to evaluate your specific situation and identify the best subscription tier for your organization. You can also visit our website, markforged.com/subscriptions, and you can get a little bit more information about subscriptions. And if you're interested, you can fill out a form and request a quote. I do apologize for any background noise there. There is a little yard work going on outside the office. So apologies for that. Okay, so Julie, are we ready to do some Q&A?
I think so. There have been some great questions in the chat, and I've been trying to answer some of them as they come in.
All right, so let's see. Looks like we got one from Sean saying, are the safety factor and deflection the only criteria to use for the load case settings? Yeah, right now we are just evaluating, how strong the part is and how stiff the part is. So we're looking at the structural aspect of the part, not necessarily any thermal aspects or anything like that. So right now it's just safety factor and deflection are the main aspects of the load cases. All right. Is it feasible to print pure copper or copper alloy, which is already placed on the platform? Do your printers have dual feeding stock for multiple material 3D printing? Yeah, so the Metal X and our PX100 printers do allow you to print with copper. Those two platforms just do single materials, but our industrial printers and our Mark II printer do allow you to print multiple materials. So you can do a base plastic material, so onyx, for example, and then you can reinforce that with a continuous fiber like carbon fiber, fiberglass, or Kevlar. All right, Julie, do you want to try to maybe answer this one here? Is there a bundle between hardware and software if we're using the entire suite?
Yeah, so I think this is really what the Digital Forge subscriptions are doing. So as you invest in our hardware, you're actually really investing in the Digital Forge. You have this unified, combined, kind of closed loop system that allows us to deliver on the reliability, quality, surface finish, etc. And most of that is actually achieved by software. We also include the education component. So this same guest was asking a bunch of questions about Markforged University and about training. And that helps you succeed. So it's not just the hardware, it's not just the software, it's not just the training, it's all of those pieces together so that you can be the most successful with your investment. The same guest also was asking about kind of one of the values of Markforged University, and I mentioned in the chat that and Rick showed you do get a certificate at the end, which is great. And a lot of people actually put that on their resumes. You'll see it on folks' LinkedIn profiles. This is a way that people at your company, people at universities or in different education programs can say, hey, I understand additive. I have gone through these programs. I know how to design for it. That is a very special skill, and that helps them as they move through the world and impact your and other organizations.
Yep. Okay, we have one more question coming here. So one purchase covers education, the software, and the device. So to clarify, when you can purchase the hardware separately. A subscription plan is not mandated. But typically what our customers do is when they do buy the hardware, they'll just add on the appropriate subscription tier at that same time. So there'd be two line items there. One line item for the device, the printer, and then just a second line item for the subscription tier that you are interested in. All right, Julie, one more question here. I am a current customer with an active success plan and Eiger fleet. How will I be affected here?
Oh, great question. So the biggest thing is that as one of our current customers, you are not, you don't have to change anything. You can live out your current subscriptions and everything that you have today. And if you would like to move to the new model, you can, but we're not forcing anyone to move or to change anything. So everyone gets to live out the investments that they've already made. But if you are interested, then we can definitely chat about moving over. There's probably some benefits for you and for your organization. So that's a great opportunity to reach out to your Markforged sales representative and partner representative, or as Rick mentioned, to fill out that, to go to our website and fill out the request a quote form, which will direct you to those people should you not remember exactly who they are.
Okay, looks like that's it for questions. So Julie, thanks for joining me on this webinar, and to all the attendees, thank you very much for taking time out of your day to join us. We hope that this webinar was informative, and hope that you now understand what Digital Forge subscriptions are and what the value they are going to bring to your organization. So thank you all and have a great day.